Okay, here we are with the third video for section 2.2. I'm afraid there's going to actually be 4 videos on this one, and I apologize, but you know what, there's a whole bunch of stuff. You get the whole week to work on it, so it's all good. The next section actually is a precursor to what we call derivatives, and derivatives will actually help you to determine what is the slope of a curve at any given point. That's one of many things that the derivative actually shows. But to tie it back to what we did last week, we know that we can find tangent lines on curves, and the derivative is a really useful thing to help us get by with that. But here we are told specifically, or asked specifically, to use what is given in the directions for the particular value for x sub 0. And so there's several things that we need to do. The first thing we need to do is this. We need to find what is f of, well, x sub 0 in, for example, number 14 is 8. So we need to know what is f of 8 plus h. Now, in number 14, it's a relatively simple, it's a linear equation, so it's not going to be too much. 2 times 8 plus h plus 5. And I apologize for why this slow writing, but we'll hopefully get something working out here shortly. And so I'm going to go ahead and evaluate this pretty quickly. 2 times the quantity 8 plus h is 16 plus 2h plus 5. And adding like terms, we get 21 plus 2h. But according to the directions, we also need to know what is f of x sub 0. Well, in, for example, number 14, x sub 0 is 8. So that's even easier to calculate. F of 8 would be 2 times 8 plus 5, or 16 plus 5, which equals 21. And so now we are actually ready to start plugging in some values. Limit as h approaches 0. Okay, f of x sub 0 plus h. Well, that's up here. That's 21 plus 2h. Minus, what is f of x sub 0? Well, what is f of 8? Because x sub 0 equals 8. That is 21. All over h. So this would be the limit as h approaches 0 of, well, notice the 21s cancel each other out, so that leaves 2h over h. Hopefully it's rather obvious. The h's cancel each other out, and so we get the limit as h approaches 0 of 2. Now here we run into an interesting question. Can I now substitute this in without causing a problem? Because if I tried substitution immediately, we would have something over 0. Not good. So I do need to do the simplification. So can I substitute in 0 in for h now? Well, the question is, where would it go? Well, since there's no h, we don't have to put it in anywhere. So the limit as h approaches 0 of 2 is simply 2. What's the limit as h approaches 5 of 2? 2. What's the limit as h approaches 10 of 2? 2. And I sure hope I heard your lovely voices saying 2 right along with me. 15 is within the same group, and so let's look at what we get there. Once again, we're going to have to do f of, let's see, we want f of 5 plus h, which is equal to the square root of 5 plus h. Ooh, not good, but that's as far as we can go with that. Then we also need f of 5, which equals the square root of 5. Oh boy, this is not going to turn out very good, but you know what? We have to deal with it. Let's just deal. The limit as h approaches 0. Okay, f of 5 plus h was the square root of 5 plus h minus f of 5, which is square root of 5 all over h. Now, if we would try to do direct substitution right now, 5 plus 0 is square root of 5. Square root of 5 minus square root of 5, 0. 0 over 0. Okay, we're messed up. So we had to do something. Now, regardless of how hard you try, I mean, it would be real nice. Can we take the square root of this and subtract that? No. You can't subtract quantities that are under the square roots. So where are we at? What do we need to do here in order to try and solve this? To which I ask, what would happen if we had the reciprocal here? If we had the reciprocal of this problem, then what we would have to do to try and rationalize the denominator is to take both the numerator and the denominator times the conjugate here. So even though this is in the numerator, let's try that. So the conjugate here is the square root of 5 plus h plus the square root of 5. But to keep things equal, we need to multiply this denominator by that exact same thing. Now let's see what we get. The limit as h approaches 0. And I do need to hold this on because I haven't substituted in 0 for h yet. But I hopefully will be able to do that shortly. Realize this is yet another method. Multiply by the conjugate, much like you were trying to rationalize the denominator. Although here we're somewhat trying to rationalize the numerator, although that doesn't really make sense. But you can think of it sort of that way. Basically, we need to get rid of some of these square roots. These square roots are just amazing. Okay? So 5 plus, or the square root of 5 plus h minus 5 times the square root of 5 plus h plus the square root of 5 is equal to 5 plus h, because those will square. The outer and the inner terms will cancel each other out. That's the whole point of rationalizing. And then negative root 5 times positive root 5 is minus 5 all over h times the square root of 5 plus h plus the square root of 5. Okay, now some simplification. The 5 minus 5 will cancel each other out, and look what happens here. This h can now cancel with that h because those are factors of each other. And so now we get the limit as h approaches 0 of 1 over the square root of 5 plus h plus the square root of 5. Now as h approaches 0, okay, this becomes, now I'm actually going to substitute, so I no longer need the limit. So it's 1 over square root of 5 plus 0 plus square root of 5, which equals 1 over square root of 5 plus square root of 5, which equals 1 over 2 times square root of 5. And then rationalizing this is pretty simple. Square root of 5 over square root of 5, which will finally equal square root of 5 over 2 times 5, which is 10. So after it's all said and done, the limit here is square root of 5 over 10. Once again, knowing the shortcut here, and this is what you want to be looking forward to. When you know the shortcut, this is a whole lot shorter. This is probably a two-step problem compared to what we have been looking at. Now, the final example that we're going to look at least in this video, and then we will eventually be able to get to the rest, it does actually require us to use the graphing calculator. So I will be pulling this up. It says use a graphing calculator to graph f near x sub 0 and use zoom and trace to estimate the y value of the graph when x approaches x sub 0. Well, really, what I'm looking for, if we look at example number 16, I want to know when x gets closer and closer to 2, what does that all equal? So, first thing I'm going to do is to go to y equals and clear out everything that I don't want or don't need. So I've cleared it all out. And I'm going to start with my default window, negative 10, 10, 1, negative 10, 10, 1. So I've got it there. And then let's go back to y equals, and let's see, I want to do that whole monstrosity there. So that would be a set of parentheses because we have a whole bunch of stuff going on in the numerator. X squared plus 3x plus 2. That is all in the numerator, so I'm going to close that out and then divide out everything that's in the denominator, which is x squared plus x minus 2. And close that out. And let's graph it, and hopefully I haven't made any mistakes. And we see that something bizarre happens. It gives us this this hyperbola sort of shape, or actually it looks more like a rational graph. But what we're interested in is right at 2, what value does it give when x is getting closer and closer to 2? Now we have several ways to do this. If we look at this graph, I'm looking at x equals 2, and it looks like, yeah, you know, that value there. Now, am I going to try and guess that? Absolutely not. What I'm going to do instead is I'm just going to hit second table, because 2 is a nice round number. So I'm going to go through and say, okay, does 2 actually give us the value? 2 gives us the value of 3. Well, guess what the limit is as x approaches 2? It's 3. Now what I want you to notice is that, notice where it says error here and error here. These are two situations or two places where we have to go into much more detail as to what would the limits be if they are actually there. But since we're asking when x is getting closer and closer to 2, what y value is it getting closer and closer to? It's real obvious, it's getting really, really close to the value of 3. So the answer here for example number 16 would be